Hello, Salwa. Do you still recognize me?
Assalamualaikum. Yes, of course.
Cannot hear you.
You didn't hear me?
Oh, is it my? Oh, sorry. Is it my? Oh, I think I need to refresh. Let me refresh first because the audio doesn't work.
Yes.
Hi again. Can you hear me?
Yes, Assalamualaikum.
Wassalam.
Assalamualaikum warahmatullahi wabarakatuh. We will wait for the chair to come in. Thank you.
Okay, Assalamualaikum. Very good afternoon. Now we reach around 10 for the at the afternoon. Okay. Before we start the sessions, please check the pre-record video presentation and the presenter attendance with the IT personnel. Live presentation are priorities. If there any technical glitch, you can request the IT personnel to play the pre-record presentation video accordingly. Okay, Assalamualaikum and good afternoon again, and very good afternoon, ladies and gentlemen. We are about to begin our poster session today, so please stand by. I would like to seek for your kind cooperation toward any virtual disturbance during the live broadcast sections. If you have any questions, the conference resource personnel are ready to attend you at the reception desk. Thank you for your kind cooperation and attentions. Okay, we will start at 12:15, which is approximately around 2 minutes from now. Are you ready, guys?
Ready?
Okay. Okay, we start. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon, ladies and gentlemen. Welcome to the first Malaysia International Conference on Nanotechnology and Catalysis, MICNC 2021. We are now in the poster sessions. My name is Dr. Nurul Aida and I am a postdoctoral research fellow at Nanopart University Malaya. I will be the session chair today together with the session moderator. The first is Madam Nur Ain Nadia binti Shapril, and next is Miss Shabila binti Sazali, and the other one is Madam Nur Azimah Abdul Samad. Okay. Before we start, I will invite all the invited speaker and presenter to request to show audio and video now. Okay, ladies and gentlemen, for the oral presentation will be evaluated for the best poster award that offer prize money from 5,000 to the 1,000 trophy and award certificate. So the winner will be announced during the closing ceremony.
Dia bila buat boleh ikut video lah.
And then I would like to seek for your kind cooperation to mute your mic if you're not presenting, and to avoid any kind of visual disturbance as possible. For those who intend to ask questions to a presenter, you can channel your question in a Q&A box. I will like it after every presentation. You can also request to show your audio and visual to ask your question in a live mode. Presenters are given 5 minutes for presentations and 5 minutes for Q&A sessions. I will remind the presenter to end the presentation 1 minute before the presentation session ends. And I will stop the presentation session when the session has exceeded the 5 minutes allowed. Okay, before we start this poster sessions, I will appreciate if everybody can turn on the camera for a photo session. So the IT personnel will take a screenshot. Okay, without further delay, you will sharing a presentation. Okay, no. Okay, so we need open the video first. And then our personnel will take the photo, right? 1, 2, 3, smile. Done? Okay, good job. Okay, next. Okay, Today we have seven poster presenter. Okay, we start with Dr. Nur Ilianti Ali Othman. Okay, without further delay, you will be hearing a presentation from Dr. Nur Ilianti Ali Othman, and the title is the effect of different concentration of sodium hydroxide on carboxymethyl cellulose properties. So please welcome Dr.
I will play the video.
Sodium hydroxide on carboxymethyl cellulose properties. Assalamualaikum and good afternoon. I'm Nur Elianti from Malaysian Palm Oil Board. Will give a short presentation of my poster entitled The Effect of Different Concentration of Sodium Hydroxide on Carboxymethyl Cellulose Properties. Here on the first slide is a layout of my full poster. As introduction, carboxymethyl cellulose (CMC) is a versatile polymer derived from cellulose. Due to its high water-soluble properties, CMC has been used widely in various industries, including food and non-food industry. In this project, cellulose extracted from all palm and tree fruit bunch was used as a raw material for production of CMC. There are three steps to produce CMC from EFB fiber. First, the extraction of hollow cellulose, and then next, the extraction of cellulose from hollow cellulose. This palm-based cellulose will go through the esterification process to produce palm-based CMC. All the CMC produced were analyzed by FTR spectroscopy technique for structure confirmation, and resulting, the CMC produced were identical to standard commercial CMC. From this table, as we can see the different properties of CMC produced. The viscosity of produced CMC in this project were categorized in medium and high viscosity range. Viscosity of CMC is an important parameter for the industry use. It provides information for flow characteristics of the fluid flow involved in processing operation and products using different concentration of CMC. Figure 2 shows that CMC3 at 2% dilution in distilled water. For the degree substitution properties, the higher degree of substitution number will improve compatibility with other solvent components such as salt and non-solvents. For purity properties, the purity of produced CMC are because of imperfection in alkalization and carboxymetallization process. This will cause more consumption of sodium hydroxide and monochloroacetic acid. This equation shows the main reaction of synthesized CMC from cellulose and also the side reaction of the hydrolysis of monochloroacetic acid. And this side reaction results the formation of sodium glycolate and sodium chloride. Overall, we can see the different concentration of sodium hydroxide does affect the properties of CMC produced. This can be explained that when cellulose treated with sodium hydroxide, sodium cellulose complex is formed. The most important is this swelling complex can enhance the reactivity towards chemical reaction compared to the original cellulose. As a conclusion, different grades of CMC were successfully synthesized in various concentrations of sodium hydroxide. The structure of synthesized CMC were confirmed by FTR spectroscopy technique, and the properties of CMC were analyzed according to STM method. This pump-based CMC has huge potential for future green chemical demand since it being produced from renewable resource and it is sustainable. This product also will increase the value of agriculture biomass. And that's all. Thank you for listening.
Okay, thank you, Dr. Nur Ilianti Ali Othman for addressing those very interesting topics. And then, ladies and gentlemen, now we come to Q&A session. Please mention your name before addressing your questions, and I will raise a question from the Q&A box. Yeah. Any questions? So Dr. Elianti, so what is the novelty in your research compared to the other research was done by other researcher, Doctor? Doctor, I can hear, Doctor. So very interesting answer. Now we go to the second presenter. I invite Kamal Salwa Jamal, and the title is the Mesomorphic and Optical Studies of Azo-ester Materials, the effect of the lateral fluoro and terminal substituents. So I welcome to the Mr. Kamal Salwa Jamal.
I think
Yes,
Dr. Aida, she's
Orin.
not in. She was here. Yeah, she was here, but
Or
she's not in.
okay,
Yeah,
okay,
she's coming now.
Assalamu
okay,
alaikum.
okay.
Maybe you need to ask again,
Assalamu alaikum.
or
Are you
maybe
hear me?
yeah, to she.
Yes, I can hear you clearly.
Okay, I will share my screen. Sorry, just I don't know, maybe hanging or what.
Yeah, that's the problem during the virtual conference, right? But it's
Yeah.
okay.
Yeah, okay, I will try now to share my screen.
Okay, please. Anybody can answer me? Did Karma Salwa Jamal is here?
I think she's not here.
Really? So, but it's okay. So we
Yeah.
go to the next presenter, Mrs. Nurul Hazira Kamarudin, and the title is Synthesis, Characterization and Antibacterial Activity, Investigation of the Silver Nanoparticle Coated Graphene Oxide Thin Film. So please welcome Mrs. Nurul Hazira Kamarudin.
Assalamualaikum. Thank you, Mrs. Chairperson. I will share my slide. Okay. Assalamualaikum and a very good day to all. I'm Nurul Hazira binti Kamarudin from University Malaya. Today, I would like to share my poster entitled Synthesis, Characterization and Antibacterial Properties of Silver Nanoparticles Coated Graphene Oxide Thin Films. Nope, sorry. Wait. Oh, I cannot. I'm sorry. You can see my slide?
Yes, Hazira, I can see.
Yes, Hazira.
Yeah, wait 1 minute. I think I need to reshare again, sorry.
Okay, Hazira.
Assalamualaikum and very good day to all. Today, I'm Nurul Hazira binti Kamarudin from University of Malaya. Today, I will present my poster entitled Synthesis, Characterization and Antibacterial Properties of Silver Nanoparticles Coated Graphene Oxide Thin Film. So here is my poster layout. It consists of introductions, experimental methods, results and discussion, conclusions, and finally reference and acknowledgement. Briefly on the introduction, among the great variety of antibacterial materials, silver nanoparticles are marked out as antibacterial reagents with high capability due to their large surface area and slow release properties. However, silver nanoparticles alone are easily agglomerated, which may affect their properties. Graphene oxide is an appropriate material to disperse and stabilize the silver nanoparticles since it combines a large specific surface area and abundant oxygenated functional group. The oxygen-containing group acts as anchoring site for the attachment of silver nanoparticles and assists to control the agglomeration of silver nanoparticles. So for this research, we aim to synthesize a uniform and a small size distribution of silver nanoparticles deposited on graphene oxide thin film using a two-step method, which are spin coating and followed by hot wire chemical vapor deposition. And finally, the sample were tested for their antibacterial properties against gram-positive and gram-negative bacteria. And for the deposition of graphene oxide thin film, firstly, we synthesize the graphene oxide using a standard simplified Hammers method. After we obtain the graphene oxide suspension, we spin coated the graphene oxide onto the thin films. And then this graphene oxide thin film will proceed to the next step using hot wire CVD. This graphene oxide thin film were used as a substrate for the deposition of the silver nanoparticles. And the sample were then characterized to confirm the formation of silver nanoparticles and graphene oxide. Firstly, we do the Raman spectroscopy study. From this figure, you can see that two samples of GO and silver nanoparticles GO. Both samples displayed two characteristic band of GO, which are D and G bands. For sample silver nanoparticles GO, the Raman band significantly increased compared to GO. This proved that silver nanoparticles are successfully attached on the graphene oxide sheet. And then we do the UV spectroscopy characterization. And we compare 3 samples for bare graphene oxide thin film and graphene oxide silver nanoparticle with graphene oxide and silver nanoparticles alone. The absorbance peak of GO shows a maximum absorption peak at 230 nanometers, while for silver nanoparticles GO, the characteristic of GO shifted to a longer wavelength from 220 to 260 nanometers, and the SPR peak appears at 420 nanometers. The appearance of this SPR peak signifies that silver nanoparticles, small size of silver nanoparticles were produced using this method. And then for silver nanoparticles only without graphene oxide, the absorption peak shows 2 peak at 270 nanometers here and 422 nanometers. The peak at lower wavelength indicates that the formation of larger size of silver nanoparticles and the SPR peak appear at 420. You can see from the FISM image here, there are 2 groups of silver nanoparticles, which consist of a larger and non-uniform shape of silver nanoparticles. And then finally, we go for antibacterial testing. These tests were done using agar diffusion method. We measure the zone of inhibition around the glass slide. For this test, I compare silver nanoparticles only and silver nanoparticles with graphene oxide. A clear zone was observed surrounding the glass substrate coated with silver nanoparticles and silver nanoparticles GO for both E. coli and S. aureus. The zone of inhibition is strongly dependent on the size, shape, and distribution of silver nanoparticles. The zone of inhibition of silver nanoparticles GO shows larger clear zone compared to the silver-only sample. It was suggested the high density of functional group of GO layers and the small size of silver nanoparticles resulted in an increase in interaction with a larger number of bacteria in the cell, thus destroying more bacteria. And finally, as a conclusion, using spin coating and hot wire CVD method, we get the uniform size of silver nanoparticles with small nanoparticle size combined with graphene oxide. The formation of silver nanoparticles is more uniform when deposited on the GO, which is confirmed by the FISM, Raman spectroscopy, and UV spectroscopy. Silver nanoparticles on bare substrate and GO-coated substrate show positive results towards selected gram-positive and gram-negative bacteria with enhancement for sample that complemented with GO. And here is the reference and acknowledgement. Thank you.
Okay, so thank you to Ms. Nurul Hazira Kamarudin for the very interesting topic. Okay, now I open for the questions. Okay, let me first to ask Ms. Hazira. In this you use silver nanoparticle, right?
Mm-hmm.
This is why you use this silver material to coat it on the graphene oxide thin films, because when we start to do research, we must know, right, the uniqueness of the material and why are you choose this material?
Thank you for the question. Firstly, silver nanoparticle is widely used as antibacterial applications. So I choose silver because of its high property to kill the bacteria, and I add graphene oxide so that the size of silver nanoparticles can be controlled, because silver nanoparticles is easily agglomerated. Graphene oxide can control that agglomeration of silver nanoparticles.
Okay, thank you, Ms. Hazira. Next, we have one question from Muhammad Azam then Muhammad Adnan. Okay, what is the parameter should be considered in a spin coating process? What is the parameter and why we use a spin coating?
Okay, thank you for your question. Why I use spin coating? Because I can get a more uniform uniform thin film, a thin and uniform film, because the parameter is only, I control the concentration and the rotation time. Also the concentration and rotation time. That's only the parameter I control.
Okay. Okay, next we get, they have all two questions. One from the Dr. Norazilawati. What is the average size of your silver nanoparticle?
Thank you for your question, Dr. Nora. The average size for silver nanoparticles, I compare two samples, silver nanoparticles alone and silver nanoparticles with graphene oxide. For silver nanoparticles alone, the average size is around 25 to 30. And for sample deposited on graphene oxide is around 14 nanometer in average.
Okay.
Yeah, that's all.
Okay, the next, from Dr. Yusliza, Dr. Yus, what is the optimum nanoparticle size that can give the best antimicrobial properties?
Thank you, Dr. Yusliza. Usually, to get a good antimicrobial properties, a small nanoparticle less than 50 nanometer can have a good properties of antimicrobial. And if you
Okay.
can control the size and shape, it will be better properties of antimicrobial.
Okay, so the last one, we have only two from the Dr. Norazila. How the graphene oxide can overcome the agglomeration of the silver nanoparticles?
Graphene oxide. Graphene oxide can overcome the agglomeration due to the abundance of the functional group on the graphene oxide. We have like oxygenated functional group. So when silver nanoparticles deposited on the graphene oxide thin film, the silver is attached to that functional group that may stabilize the shape and size of the silver nanoparticles.
Okay, the last, not least, in your opinion, they have any alternative material that can replace silver from the Muhammad Azam, then Muhammad Adnan? Okay, what the material can replace for silver?
Actually, thank you, Dr. Azam. Actually, there are a lot of material that usually can be replaced for silver, and gold nanoparticle can also be used to replace the silver. However, gold is expensive, so
Yes.
it is more preferable to use silver for antibacterial application.
Okay. Okay. Thank you, Miss Nura Hazira, for the interesting topics. Okay, next we move to the other participants. So I invite Mr. Abdul Khalid bin Mokhtar, and the title is a synthesization of polymer grafted gold nanoparticles via gamma radiations. Please, Mr. Abdul Khalid bin Mokhtar.
Assalamualaikum and good evening to everyone. Okay. Today I'm going to share to everyone regarding our research regarding synthesization of polymer grafted gold nanoparticles via gamma radiation. This is my full poster and we will go through it one by one. Our study focused on synthesizing polymer grafted gold nanoparticle using PTFE as polymer by Turkovic method and gamma irradiation to graft PTFE onto the gold nanoparticle surface. And what we have found out is the concentration of gold nanoparticle is lower on 0.5 and 2.0 kilogray due to aggregation and deformation of precipitation after 30 days compared to 5, 10, and 20 kilogray irradiated PTFE gold nanoparticle solution. Our methodology is first we synthesize the gold nanoparticle via Tukovic method, and we obtain about 20 nanometer of gold nanoparticle in size. And then we add PTFE solution into the gold nanoparticle. After that, we irradiate them at 0.5, 2.0, 5, 10, and 20 kilogray. And lastly, we wash it by centrifugation for characterization. We use UV-vis analysis for size approximation and optical density, and naked eye observation for visible aggregation and color changes. Our findings, we can see the top left from left, the transition color of hydrochloric acid, chlororic acid from yellow color to clear solution, and deep purple in gold nanoparticle synthesization via Tukovic method. Uh, we characterize it using UV-vis, and what we had find out is the optical absorbance has a peak at 520 nanometer, indicating the approximate size was 20 nanometer. There's a gap in optical absorbance between 0, 0.5, and 2 kilogray, with 5, 10, and 20 kilogray. As we can see, there's a gap. This gap indicates the lower concentration of PTFE gold nanoparticle. And the non-irradiated PTFE gold nanoparticle are well diffused despite some aggregation. 0.5 kilogray shows a bit of aggregation, while 2 kilogray shows the most aggregation. And no visible aggregation for PTFE gold nanoparticle irradiated with 5, 10, and 20 kilogray. For me, the conclusion is the UV-vis data obtained showed that the size of PTFE gold nanoparticle produced is 20 nanometer with 520 nanometer absorption peak value. With absorbed dose of 0.5 and 2 kilogray, long-term shelf life is lower compared to 5, 10, and 20 kilogray. The type of polymer and way to synthesize them together with grafting to or from gold nanoparticle is limitless, and we can use other sorts of polymer to synthesize more precise and targeted radiotherapy. Thank you.
Okay, thank you, Mr. Abdul Khalid bin Mokhtar. So I open to the audience. If you have a question, okay, that's good. We have one from the Mrs. Lia Zaharani. Thank Mr. Abdul Khalid. May I know how you do optimize the condition of materials to get the best product?
Thank you for the question. We optimize the condition of materials to get the best product by we test the parameters one by one. The parameters that we had tested are the molar ratio, the pH, and the concentration. And we are using very high purity of chlororic acid.
Okay, and Madam Salwa, you have a question? Okay, we have one other question from Dr. Muhammad Azam bin Muhammad Adnan. Hi Khalid, can you explain why you Turkish method in synthesizing gold nanoparticle compared to other method that available?
Thank you for the question, Dr. Muhammad Azam. We use Tukovic method because it is a direct method to produce gold nanoparticle. As we only needs to heat the chlororic acid solution at boiling temperature, and then we add sodium and ACT to the solution, and we stir it vigorously, and then we get gold nanoparticle within 30 minutes.
Okay. Okay. I have also one question because before this I have used gamma radiations to treat my materials. So in this case, which parameter you use. You go to the kilogray or the gray for your dose of the source from the radiation to your materials.
I'm using kilogray.
Kilogray, how much is it? So
Uh,
you,
I'm starting my irradiation from 0.5 to 20 kilogray.
so what is the your source of the gamma radiations?
Um, Gamma cells cobalt 60, I think.
Yes, cobalt 60, that's it.
Uh,
So you radiate that with that synuclear, right? You can?
yes,
Yes,
yes.
okay, that's good. Okay, thank you,
Thank you.
Mr. Abdul Khalid bin Mokhtar. Now we go to the next presenters with the Thai.
Present.
Doctor, Madam Sawa, you have
I'm
questions?
Salwa. Can I
Pardon?
present now?
You want to present now?
Yeah.
Okay, okay, please, sure, can.
Okay. I will try to share again.
Okay.
Did you see my screen?
I cannot see.
Okay. Maybe just 1 second. Will appear now.
Okay, take your time. That's no problem.
Sorry, I don't know what's happened.
But it's okay. Sawa, it's okay, Madam Sawa.
Yeah, you can see now.
Yes, I can see.
Okay.
Okay, you can see that.
Very good. Okay. You can see now all my screen.
Yes, I can see. Okay, that's nice.
Okay. Okay, I will start now.
Okay.
Assalamu alaikum at the first and good afternoon. I am Salwa Kamal, PhD student at Malaya University. Today I will present some of my research work on the mesomorphic and optical studies of azoester materials, effect of lateral fluoro and terminal substituent. Sorry, can you hear me?
Yes, yes,
Hello?
Sawa. We can hear you. Please proceed.
Oh, it's okay. Okay, okay. Okay, at the first, what is liquid crystal? Liquid crystal is an intermediate state between the crystalline solid and the ordinary liquid phase. Liquid crystal molecule structure must consist of rigid structure that called mesogene and flexible chain known as spacer unit. Liquid crystal can be found in digital watches, TVs, cell phones, calculator, digital camera, and thermometers. Our methodology: synthesis of three benzene ring molecular core of azoester compound bearing lateral fluorine group with 2-methyl-butoxy terminal group on the phenyl azo side, and the second terminal group had either electron donating or electron withdrawing group. As you can see, compound F1 with hydrogen, compound F2 with methoxy, and compound 3 butoxy, compound 4 bromo, and compound 5 with nitro. The chemical structure for all compound determined by FTIR, proton and carbonyl R. The thermal decomposition were investigated by thermal gravimetric analysis. The mesomorphic properties were investigated by differential scanning calorimetry, polarizing optical microscopy, and small and wide-angle X-ray scattering. The optical properties were studied by UV visible and photoluminescence spectroscopy. Result and discussion. FTIR proton and carbon NMR result confirmed that all prepared compounds are agreeing well with the structure assigned. The thermal stability for all compounds studied by TGA, as you can see, single-stage thermal decomposition were observed for all compounds within the temperature range 260 and 460 degrees centigrade. The thermal decomposition were suggested due to the thermal cleavage of azo group and aliphatic chain located in the mesogene. The mesomorphic properties were studied by DSC, POM, and SWAX. As you can see in the DSC thermograms, the unsubstituted terminal compound F1 showed only one transition peaks, transition from crystal to liquid, without trace of liquid crystalline phase, while compound F2 and F3 with methoxy and butoxy terminal substituent showed two transition peaks, transition from crystal to nematic phase, then transition from nematic phase to isotropic phase with the grainy and chiltern texture respectively, while compound F4 with the bromo terminal substituent showed three transition peaks, transition from crystal to nematic phase, then transition from nematic to another nematic phase, then to isotropic phase with both chiltern texture. The compound F5 with nitro terminal substituent showed two transition peaks, transition from crystal to nematic phase, transition from nematic to isotropic phase with higher clearing temperature compared to the other derivative with chiltern texture in POM. The first transition for all compound confirmed by SWAX experiment. As you can see, in 25 degrees centigrade, all compound showed multiple peaks at wide angle, typically for the crystalline phase, while a highly diffuse scattering peak were showed for all compound, confirmed the formation of the nematic phase. The optical properties for all compound studied by UV phase and photoluminescence spectroscopy. As you can see in the UV spectra, the broad absorption band were appeared around 300 and 420 nanometer, attributed to the pi stars transition to the whole, in the pi electronic system throughout the whole molecule, while the photoluminescence spectroscopy observed blue emission and was redshifted with the incorporation of the nitro substituent. My gratitude and thanks to my supervisor in University Malaya, and thanks to Imam Abdurrahman bin Faisal University, thanks to Nanocat to give me this opportunity.
Okay, thank you, Mrs. Salwa Jamal, for a good and interesting topic. Now I open to the questions. Now, yeah, we have get one from the Dr. Siti Maria Muhammad Yassin. Hi, Mrs. Salwa. Due to a very short presentation timing, I want to know more of azo-ester material. It is one of kind of liquid crystal material.
Of what?
We have get one question for you, Mrs. Salwa. Due to the very short presentation timing, I want to know more of azo-ester material. Is it one of kind of liquid crystal material?
Yes, it's a kind of liquid crystal. Yes. The first one also only we
Mrs. Salwa, you mute that. You please unmute your. Mr. Sarwa Kamal, you mute it. We can hear you. Mr. Sarwa, please unmute. We cannot hear you. So, okay, we have got a problem here. So, okay, yeah, maybe Mr. Salwa can answer all the questions in chat box. Okay, next, I will invite next presenter. The title is the effect of graphene and graphene oxide to the polyvinyl fluoride, Pvdf for biomaterials. So I invite Mrs. Nur Azri Khalisa Aznan.
Hi everyone, can you hear me?
Yes, I can hear clearly. Please.
Okay, so I will share my screen first. Can you guys see my screen?
Yes, we can see.
Okay, can I start now?
Yes, sure, please.
Okay, Assalamualaikum and a very good afternoon everyone. So my name is Nur Azri Khalisa. So today I will present my research work on title effect of graphene and graphene oxide to polyvinyl fluoride for biomaterials. So as an introduction, why Pvdf? So actually Pvdf is a semi-crystalline polymer. So why Pvdf? It is because it is specialty plastic used in application requiring highest purity. It is resistant to solvent, acid, and hydrocarbons. It's non-reactive. It's FDA compliance and non-toxic. And last but not least, it has efficient piezoelectric and pyroelectric properties. And next, sorry, I should. Okay. So next, graphene and graphene oxide. Every well known as a super material or miracle material due to its excellent thermal conductivity, very high Young modulus, and also excellent chemical stability. So come to this research. So the research question, my work is how to improve the lifespan of the biomaterial for a lifetime, and then second, how to improve how to optimize the materials to be flexible, antibacterial, and also biocompatible. So okay, so basically for my work, I'm using a solution mixing technique. So so Pvdf graphene and Pvdf graphene oxide being synthesized using two different temperatures and different concentration of graphene and also graphene oxide. And then after that, followed by characterization to study their structural, thermal, and also mechanical properties. And then after that, we'll do cell grow culture for in vitro studies for biocompatible properties. So as a hypothesis of this research, so nanocomposite of Pvdf with graphene and graphene oxide nanofillers were hypothesized to have enhancement in mechanical properties, biocompatibility, also antibacterial activities. So as an initial findings discussion, so this A image showing SAM image of endothelial cells on Pvdf graphene nanocomposite, and B confocal image of endothelial cells on the Pvdf graphene composite surface. So it shows that Pvdf graphene nanocomposite successfully can grow cells on top of it. So it gives potential as a application for biomaterials. And then comes to the result, FTIR result. So okay, for FTIR result for Pvdf powder and Pvdf graphene, and also Pvdf graphene oxide nanocomposite. So it shows that there's a transformation phase from alpha phase to beta phase. So okay, for biomaterials, it needs to be Pvdf need to be in a beta phase. So at first, I thought I planned to use graphene and graphene oxide to transform the phase. However, while doing this FTIR, I found that without any fillers, it also can change the phase. So due to that thing, I also try to use different solvent to see the effect of different solvent to the transformation of this alpha to beta phase. So it shows that solvents such as DMF and DMSO also can change the alpha polymorph to beta form, while there is no change of polymorph in other solvents such as deionized water and dichloromethane. So I guess it is really depends on the dipole moment of the solvent. So not on due to that things. Okay. Next is the SRD result. So Pvdf powder shows three characteristic peaks around 2 theta, 18.5, 20.1, and 27. So associated to the reflection of alpha 0 to 0, beta 110, and also alpha 111 polymorph respectively. So it can be observed that in Pvdf film, Pvdf with 1.5% of graphene at 60 degrees Celsius, and then Pvdf graphene of 1.5% graphene at 90 degrees temperature, and also Pvdf with 1.5% of graphene oxide at 60 degrees Celsius. The distinct alpha peak at 2 theta at 18.5 degree change to beta characteristic shoulder peak at 19.92, 20.22, 20.12, and also 20.38 degree. So so an alpha peak at 27 degree completely disappeared. So because of this, so since this is still ongoing research, so after this I'll study the piezoelectric properties of the sample, either with a graphene or also different solvent, and then also study thermal properties of the sample and mechanical properties, and also last we'll do again the in vitro studies using cell growth culture. Thank you.
Okay. Okay, thank you, Miss Nura Azri Khalisa, for a good and interesting topic. Now, we go to the Q&A sections. Now we have one question from the Miss Lia Zaharani. Thanks, Miss Nura Azri. May I know how do you selected the characterization process, testing process for your products that are suitable for your product?
Okay, thank you, Miss Leah. So for characterization process, uh, uh, refer back to my objective of my research, where I want to have for uh, biomaterial application. So I really need to check their structural studies, very important, because I really need the product should be in a beta polymorph, and then also for thermal studies also important to this. So that's why doing also for thermal study, and also the mechanical properties, and also what the piezoelectric. I think this is very important to be characterized for my product, where include Pvdf and also graphene.
Okay, we have two questions. For the first is Dr. Yusiza Yusof. Miss Nurul, may I know what a beta phase is most preferred for your biomaterial applications? You already answered the answer, right?
Yeah, for biomaterial, yeah, it needs to be in beta phase. So actually, Pvdf itself is very stable in alpha phase. However, that alpha phase is not it's not going to be it's not suitable for biomaterial application. So due to that, we need to make it transform to beta phase, where suitable for biomaterials. So that's why I need to do some modification to the Pvdf, so that it can be transformed to beta phase.
Okay, that's good. Next, we have one question from Dr. Muhammad Hafiz Ahmad. Thanks, Mrs. Nurul. Based on your understanding, it is safe using graphene and graphene oxide for biomaterials.
Okay, thank you, Dr. Muhammad Hafiz. So for biomaterials, so actually there's a lot of biomaterials is a very quite wide application. So it depends on for graphene and graphene oxide. Actually, it depends on percentage, how many percentage, concentration of graphene and graphene oxide into that composite. So due to previous studies, it shows that there's graphene and graphene oxide used for biomaterials, but in certain amount. So that's why we need to do in vitro studies, where we need to do the toxicology test and also antibacterial testing.
So the graphene is toxic or non-toxic?
For graphene is non-toxic, but for graphene oxide, it is more toxic for graphene oxide.
Okay. Okay. We get one question from Dr. Muhammad Azam. Hi Nurul, PVDF is a semi-crystalline material. What happens if we change the amorphous material?
Means that previously used another amorphous material, is it?
Yeah. This is semi-crystalline material, and then what happens if we change to the amorphous material? What your comment for this?
Oh, okay. I'm not really known about others materials, as I know, because for I choose this PVDF because it has due to its piezoelectric properties, and also its stability, and also because of non-reactive, and then resistant to solvent and acids, hydrocarbons, and also because of FDA compliance. That's why. So I do really focus on other amorphous material.
Okay, thank you, Miss Nurul Azikalisa, for a good, interesting topic. Okay, next we move to the next The next presenter is, with the title is Regioselective CH Oxygenation of Anthraquinones. So I welcome Dr. Chi Chen Fei. Please, Doctor.
Hi. Title of my presentation today is Regioselective CH Oxygenations of Anthraquinones. Anthraquinones are the most widely studied organic redox active species that soluble in aqueous solution. These organic molecules are essential for redox flow battery to function properly. Redox flow battery is rechargeable electrochemical energy storage devices that utilizes the oxidations and reductions of two electroactive species, charging, absorbing energy, and discharging, delivering energy. It solves the mismatch between the intermittent supply from renewable energy resources and their variable demand. However, recent development of anthraquinone-based redox flow battery has been stagnant due to lack of a suitable method to produce hydroxylated anthraquinone such as compound 2 shown here that has been shown to possess excellent electrochemical properties. Most of the anthraquinone discovered so far are either prepared from multi-step synthesis or rely on natural product isolation. Both these processes are tedious and unproductive. In this work, our aim is to develop a new method for direct hydroxylations of anthraquinones. Specifically, hydroxyl group will be introduced at the auto positions of anthraquinone by using inexpensive and environmental benign reagents while CH activation approach. Our preliminary findings have shown that this method is able to produce a variety of auto-hydroxy anthraquinones in good yield. We are currently expanding the scope of substrate and investigating the mechanism of action. Hopefully, this method will serve as an important milestone for organic redox flow battery development. We thank University Malaya and Nanotech Research Center for providing research funding and facilities. Finally, thank you for your kind attention.
Okay, thank you, Dr. Chi Chen Fei, for the interesting topic. So, Dr. Okay, now I open the questions to all the audience. Oh, very sorry because Dr. Chi cannot join us. Okay, Doctor, I can only type. Okay, now we reach at the end of the sessions. Thank you for the participations. Okay, right now we before we stop here, on behalf of the MICNC 2021 organizing committees, I would like to seek for your kind cooperation to fill up the feedback from the form as given by the session moderator in the chat box. You are invited to join the rest of the events. Now, before we stop, right now around 1:20, we still to wait because we need to announce who the best presenter for the poster presentations. Also, I would like to all the audience to enjoy to the at the our expo. Thank you. Okay, Assalamualaikum. I'm sorry for there has a problem here. I am sorry for that because there's some the technical problem. So we will announce the best presenter award on the closing ceremony by the end of the conference. Thank you all. Stay safe and goodbye. Assalamualaikum.
Waalaikumsalam.
Terima kasih.
Thank you.